Hi, I'm Mike Zyda, and today's presentation is entitled, Buddy, Can You Spare Me 44 Gigawatts of Power for My AI Data Center Collection? Today is the 12th of November, 2025, and this is a video I'm making for my IEEE computer column, which will come out months from now, but I recorded early. Okay, let's share the slides. Share the slides. There they are. Share. Cool. Let's put it up on play and continue to share. There we are. All right. You love the new IEEE column header artwork. Cool. In a past column, I discussed a few of the prominent AI data center projects in development. And in this column, I discussed the scope, size, and enormous cost of building 50 large AI data centers globally, and there's a whole lot more than 50. But I'll just try and discuss them briefly. So the real question is, how many large AI data centers are already built? In reference one, I attempted to create a new term, massive machines, a term I thought would be easier on the eyes than always writing out AI data center. AI data center seemed to me to be constraining in that maybe it's not just AI that is computed in these facilities, but no one had time to read reference one. So we're going to stick with AI data center in this column so as to not confuse the intransigent. I started working on this column by asking ChatGPT 5.0 how many large AI data centers are being built globally. And I received a page of detailed and philosophical answers to my question and the meta questions inside of my question. So I'm not going to give you all the pages of response, but edit it down to the important parts. So when you see it says ChatGPT : this is what ChatGPT response is. And so the response is there is no publicly available precise count of how many large AI data centers are being built globally, but several credible sources provide useful estimates and context to gauge the scale of the build-out. Here is a summary of the key data and what it suggests. And according to McKinsey & Company, the demand for AI-ready data center capacity will rise at about 33% per year between 2023 and 2030. 33% per year. That's a very big growth. And I put a dot to dot because I cut some stuff out. And it goes, from a region or country viewpoint, only 32 countries host AI data centers specialized for AI. Today, the US and China dominate the market. We learned a couple of things from the brief repartee with ChatGPT. And one is that ChatGPT is either British or from some colonial enclave of the UK. You see the spelling of specialized with an S instead of a Z. It's a pure sign of that. Another thing from this quote from ChatGPT, the demand for AI-ready data center capacity will rise at 33% per year between 2023 and 2030. And I decided to reach back to the actual McKinsey online article that ChatGPT referenced to find out what they really said, and that's reference two. Our analysis suggests that demand for AI-ready data center capacity will rise at an average rate of 33% a year between 2023 and 2030 in a mid-range scenario. So that quote that ChatGPT gives me is for a mid-range set of AI data center construction. So that means there's a smaller number and there's a much bigger number than 33%. We're just going to leave it at 33% here, but it actually could be larger. So 33% average rate of growth is mid-range. The McKinsey article also indicated that in 2023, there were currently 60 gigawatts worth of AI-ready data center capacity globally. So you notice one of the things that happens with the AI data center is that instead of talking about millions of instructions per second or giga instructions per second, it talks about the power consumption of the data center, because I guess it is linear from how many GPUs you have to how much power requirements you have. So if I've done my math right, this means that by 2030, we will have a capacity for 559 gigawatts of AI computational capability globally. And that's a power number. That's how much power that global set of AI data centers is going to require. So they took the AI data center capacity in 2023 being 60 gigawatts, and I multiplied by 1.33 to get the 2024 capacity, 80 gigawatts, and then multiplied that by 1.33 to get the 2025 capacity, 106 gigawatts, and so on until 2030, capacity of 559 gigawatts. It's huge. So I asked ChatGPT how much power generation capacity is in the United States currently, and it said 1.19 terawatts. 559 gigawatts for AI data centers globally is 47% of the current US power capacity. And so the power requirements for AI data centers is huge. And, the biggest issue is, do we have that much spare capacity and power? And if we don't, how fast can we build power? All right. So if my maths are right, and ChatGPT and McKinsey are right, we need to create a power generation capacity globally of about 47% the size of the United States current power grid. I don't believe we're going to make that growth rate, by the way. But if you believe it, you should be investing in NVIDIA and all of the companies that build AI data centers and all of the companies that make and build the power generation capabilities that AI data centers require. Or we could just plug into the existing grid and watch the power grid die. All right. ChatGPT said, perhaps, I asked it a question, how many large AI data centers are being built in the world? And it said, perhaps over 100 large AI data centers are currently being built globally, i.e. in construction or announced in the 2024 to 2026 timeframe. And ChatGPT told me, it says, if you like, I can pull together a list of specific announcements of large AI data center builds with site, capacity, company to give more concrete numbers and examples. Would you like that? And of course, ChatGPT gave me a curated list of the top 50 AI data centers, which is tables 1A and 1B, which are truncated from the spreadsheets. I'll put a link for the full spreadsheet in this paper. And in this talk, it never gives you the complete list of perhaps over 100 large AI data centers right away, as it wants to keep your attention, is my belief. Maybe it gets lonely, or perhaps it is too tired to provide a complete answer. To understand that list of top 50 AI data centers, we need to first talk about AI data center power technologies and power build time and AI data center build time. So here's tables 1A and 1B, and it's all small print. I'll just leave it up here a second, or the top 50 are on this slide. If you pause the video, you can go read through it. And what it basically, number one is OpenAI / Oracle / SoftBank, Stargate. There are 5 new US sites in Texas, New Mexico, Ohio, and Midwest, and expects to use 7 gigawatts on the path to 10 gigawatts of power just for site number 1. Pretty big. And it goes on. You can go read the rest of them. So what power technology is needed in their build time? With respect to power for AI data center, the question is how fast this power requirement can be met and at what scale, because right now the AI industries want to grow as fast as possible. And a follow-on question might also be, do we have enough power infrastructure construction capacity? So I asked ChatGPT how long it took to build a 1.5 gigawatt power plant for each of the major power generation technologies. A 1.5 gigawatt power plant is kind of like the Moss Landing facility up, between Monterey and Santa Cruz in California, and it can serve a community of about 1.5 million people, according to the Moss Landing website. So for renewables, solar and wind, a range of 1.5 to 3 years was provided as an estimate for that size power plant. For hydropower, most of those are already constructed power plants that require significant transmission line buildouts from the hydropower source to the new AI data center. For gas-fired combined cycle power plants under decent conditions, the range provided was 2.5 to 4 years for a 1.5 gigawatt power plant. For nuclear, the range provided was 5 to 10 years to build a 1.5 gigawatt power plant, unless you had a nearby mothballed facility like 3 Mile Island that could be resurrected without controversy. And I'm not sure what the quote on that is, but Microsoft is investing in that with an energy company. For mobile gas turbines, like those used by Elon Musk's XAI facility in Memphis, they can be installed in several months if the requirement for building permits is ignored and the location for the highly polluting gas turbines is across the border in a state that has no care about pollution. Note, 39 mobile gas turbines have been installed at the XAI facility across the border in Mississippi, not Tennessee. So if you do kind of play that kind of game, you can get things up quickly. And I think Elon Musk got his entire XAI facility built in 4 months by doing that. Now, a note in tables 1A and 1B, we will see that some of the AI data centers being planned are in the 7 gigawatt to 10 gigawatt range. And so just scale up the 1.5 gigawatt development times appropriately. In fact, the total required power for the top 50 planned projects in tables 1A and 1B is 44 gigawatts at a minimum. Okay, so we got a minimum number out of ChatGPT. This is almost a doubling of the current 60 gigawatts being used today. AI data center build times. The time it takes to build an AI data center varies greatly depending on the location and size of the facilities desired. And tables 1A and 1B show times of from 1.5 to 7 years, with the 7-year facilities being some of the largest in scale. And each of these AI data centers needs specialized building construction, significant air conditioning to cool the racks of AI servers, and transmission lines to the power generation source, and of course, water for cooling source as well. Since I was having such a good time chatting with ChatGPT, I asked it what kind of internet connection is expected for each of the top 50 AI data centers put it in the CSV, basically an Excel spreadsheet. It made for me before. I said, put in the networking requirements, and what network speeds and what network technologies are proposed to connect the AI data center to the internet. So if you're thinking you just call up Xfinity or Spectrum and say, put me in a network, it's not the same speeds. ChatGPT's answer, shortened for appropriate column brevity from here to the end of this paper section, AI data centers, especially GPU clusters, require orders of magnitude higher bandwidth than conventional cloud sites because they move petabytes per second internally and need massive external ingress and egress for training data, inference, and replication. So this is a big data pipe. So that has to be built out. And if you put this somewhere in Memphis, there may not be a close connection to the internet, but maybe there is. You know, if you're in Tennessee, you've got the Tennessee Valley Authority, which I guarantee you has a very big internet connection, internet connectivity. So table 2 is aggregate bandwidth requirements for AI data centers, all right? And so you'll see some of the things that they're thinking about are gigawatt scale AI campus. If it's greater than 1 gigawatt, it needs 100 terabits per second aggregate. And the terabit DWDM rings and submarine and terrestrial backbones, such as Stargate and the Microsoft Fairweather project. If you're just a large hyperscale AI region, 100 to 300 megawatts, you need a 10 to 50 terabits per second external, and you need dozens of 400G 1.6 terabit per second links to Metro IXSs and private backbones. And OpenAI and Meta AWS have used this for their training fabrics. And small AI pod training cluster, if what you're building is 10 to 50 megawatts in size, you need 2 to 10 terabits per second external, dual 400G or 800G trunks, and many peers used for regional inference and edge AI. So you can see the internet connectivity, which I don't see anybody talking about much, is huge. Is all this AI data center growth financially practical? Good question. Here are some thoughts that come off the top of my head nearly instantly. The first is that AI GPUs are obsolete in 3 years and depreciate rapidly. So if we're doing business with AI GPUs, we must buy new AI GPUs every 3 years to stay in business. And the delivery time for the order of our new AI GPUs could be from 1 to 3 years. So one of the immediate thoughts to have is that AI GPUs, while currently listed as CapEx, capital expenditures, they are really OpEx, operational expenditures that you use over 3 years and then they expire. And thinking this way, the profitability of our AI venture must be computed quite differently than which I think most people are thinking about right now. So if we look back in history, the railroads bankrupted the carriers, but were useful for 100 years, despite that, as the railroads were capex, something of long-term utility. Optical fiber installation bankrupted the carriers, I think WorldCom in 2002, but dark fiber gave us the 2010 boost because the fiber installation was capex, something of long-term utility. A 3-year-old AI GPU is recycling. Right now, though AI is totally OpEx with the industry, or it's listed that way, the industry has to replace very expensive GPUs almost constantly to stay in business. And the last time we spent 1/10 of our budget on OpEx, we had the 1999-2000 dot-com crash and then junk bonds in 2008. So anyway, despite these thoughts, I asked ChatGPT, how much will it cost to build all of the top 50 data centers, including building, construction, power infrastructure, internet provisioning, and AI servers? And ChatGPT's response is in tables 3A through 3D, and I'll kind of walk through a little of them with you. I have a spreadsheet where it put all of that information, and it's actually quite cool. So find that link and download it. It's up there now on the internet. Table 3A is the updated cost framework, including 4 building blocks of building and materials and equipment, M&E, power infrastructure, network provisioning, and AI servers. How much do they cost in terms of GPU racks? Table 3B is total project cost with multiple assumptions and choices, and AI server pricing assumptions. Table 3C is grand summary of costs, plus a note that AI server costs are about 72 to 74% of the total cost of building an AI data center. And that stuff expires in 3 years, all right? Table 3D is the summary cost for all 50 of the planned AI data centers, again, with a low base and high set of assumptions and associated costs. And we need something like 44 gigawatts of power minimum to run these 50 AI data centers. And this is not all of the AI data centers being built, just the top 50 that ChatGPT could find. So here's table 3A. And what you can see here, if you look at the top, it says component description, typical 2025 USD cost per megawatt of IT load. So you'll see building in M&E is physical structure, cooling, UPS, switchgear, chillers, immersion liquid systems, 14 million per megawatt base. Okay, so it computes this in terms of power requirements. Power infrastructure, substations, transformers, generation, transmission upgrades, 1.8 million per megawatt base for the base. Again, base is the middle range of construction. Network provisioning, DWDM, fiber, routers, optical backbone integration, and it's 35 cents per million, 35 cents million per megawatt base. And AI servers, GPU racks, compute nodes, it's 30 to 60 million per megawatt base. Again, depends on GPU type and density. So you can see the cost assumptions per megawatt are listed here, and I'll just let you look at these individually. This is going to be in my IEEE computer paper, but it's also going to be on my website, MikeZyda.com, under /IEEE_computer, to where you can find this video pointer, and also the draft paper will be there until IEEE computer typesets the paper. It takes them about 2.5 months. Okay, next, table 3B, total project cost with multiple assumptions and choices. And you can see total project cost, and you can see if we're doing AI servers and we're doing the high version, and we're building 50 sites. It's the AI servers, the cost of building all 50 of those is going to be about 2 terabyte, 2027 billion dollars. So it's 27.5 billion. All right. So it's a lot. So it's 2 trillion plus to build the high version. And for the base version, it's 1.5 trillion. And for the low version, it's about 1 trillion. So building these big 50 projects is very expensive. 3C, grand summary of costs, plus a note that AI server costs are about 72 to 74% of the total cost. That's, again, what ChatGPT comes out with. And again, this is exactly what I read to you. So high case, $2 trillion. Base case, 1.53 trillion. Low case, 1 trillion. This is a lot of money. The full build out of 50 major AI data centers is going to cost between $1 and $2 trillion, depending on GPU class and scale. And the AI compute hardware cost dominates. It's 40 to 60 million per megawatt of IT load, and construction and power networking at another 11 to 21 million per megawatt. And lead times 3 to 6 years to complete all phases if fully funded. Right? So you don't buy the GPU. Well, I guess you put the order in for the GPUs, and if it takes 6 years to fund it, then you've got to have other 3 years. You get order new ones 3 years after you are halfway through the project. All right. So here's the breakdown of 50 data centers. It's 250 billion for buildings, 30 billion for power, 5 billion for networking, 750 billion for servers for the low version. For the high version of the 50 data centers, it's 450 billion for the buildings, 63 billion for the power, 15 billion for the networking, and 1.5 trillion for the servers. So that is how much it costs to build all 50 AI data centers. Some additional things to think about. In reference 5, Wired Magazine tells us that we are building the AI data centers in all the wrong places, environment-wise. That article provides a guidance as to where it would be better location-wise and environment-wise for AI data centers being built in the USA. Closer to water and closer to natural power. It also provides a set of decision criteria that could be utilized globally to make the world a better place. And I have the link to this article in this talk and in the paper. And it kind of requires you have a subscription to Wired Magazine, which is maybe not a bad thing. Article 6 is my all-time favorite reference with respect to AI data center construction. 2 such AI data centers being built near NVIDIA in Santa Clara, California, are finished, but they're still multiple years away from being connected to the local power grid. In fact, I think it said 3 years plus. Since AI data centers are described in terms of gigawatts required, this is an error for the books, right? Somebody went and built this beautiful facility here. It looks awesome, but you don't see any lights on because it's not connected to the power, and it's basically an empty building. And hopefully 3 years plus from now, when the power is plugged into this building, this building is still okay for the future AI data center. So here are the references. My Massive Machines paper from IEEE Computer of November 2025. Article 2 is AI Power, Expanding Data Center Capacity to Meet Growing Demand, which came out in October 2024. This is on the McKinsey website. Tables, you've got I got those created by ChatGPT. The full detailed spreadsheet for table 1 is at this link right below, reference 4. And that's a great link. Get that, download that. That's in my Dropbox, but it's an open link that you can get to. And you'll see how interesting ChatGPT put together all of the numbers for building out 50 large data centers simultaneously. All right. I'm going to skip this. Reference 5 is if the US has to build data centers, here's where they should go. A new analysis tries to calculate the coming environmental footprint of AI in the US and finds that ideal sites for data centers aren't where they're being built. That's in the title. Data centers in NVIDIA's hometown stand empty, awaiting power. Okay, I already talked to you about that. And I wish to thank Jasper Jensen, who's the CTO of Versus and a longtime startup friend, for many interesting technical discussions that helped this column come together. And this is my contact information, Zyda at MikeZyda.com. That's my website. There is a link to all of my IEEE computer columns there. And this has been the games column for IEEE, and you're out of stopping that share. I'm back here. And you have a great day, and I hope you enjoyed this. And this has been the IEEE Games, Film, and Generative AI column. I'm now the editor for all those 3 areas smashed together. So if you have an idea for a column, send me a title and an abstract, Or if you've already written the column, send it to me directly and I'll take a look and see if it can be a future column. Because I write every other month, and for the alternate months, I've been putting in guest columns. Anyway, have a great day. Bye-bye.